Questions on the homework from this chapter? So on number 7, what zeros did you get? So we should be looking for 6 zeros here. And with graphing, so we have -7, 0, 1. For number 7, -7, 0, 1, and 8. So for this one here, we should have 6 zeros. And the graphing calculator gives us 4. And at this point here, we'll do synthetic division. Now we are missing the constant term, so we'll fill it in as 0. So the first one I'm going to check is, or use to decrease the power, is 0, because 0 times 10 is 0. -19 plus 0 is -19. 0 times -19 is 0. -573 plus 0 is -573. -573 times 0 is 0. 547 plus 0 is 547. 547 times 0 is 0. 1,211 plus 0 is 1,211. Multiplied by 0, we get 0. We add 1,176. Negative 1,176 plus 0 is negative 1,176. Multiplied by 0, we get 0. And 0 plus 0 is 0. So we ended up just recopying the whole line down, but it is 1 less. Now we're going to do this again with 1. 10 times 1 is 10. -19 plus 10 is -9. 1 times -9 is -9. -573 plus -9 is -582. 1 times -582 is -582. 547 minus 582 would be 5, -35. 1 times -35 is -35. 1,211 plus -35 is 1,176. 1 times 1176 is 1176. And our -1176 plus 1176 is 0. Let's save -7 for last. We'll do 8 next. Now, the order in which we do these really doesn't matter. We just need to pick one and do it. So 8 times 10 is 80. -9 plus 80 is 71. 8 times 71 is 568. -582 plus 568 should be -14. -14 times 8, -112. -35 plus -112 is -147. Does anybody know what 8 times -147 is? Yeah. -1,176. That's how we get 0. Then the last one we need to do is -7. -7 times 10 is -70. 71 plus -70 is 1. -7 times 1 is -7. -14 plus -7 is -21. -21 times -7 is 147, which gives us 0. It is. No, you're good. I just forgot to write it. So what we're left with is 10x squared plus x minus 21. So we could try factoring this or quadratic formula. Well, we can check to see if it is factorable. Our b squared minus 4ac. B in this case is 1, a is 10, c is -21. Second square root. 1 squared minus 4 times 10 times -21 is 29. That is an integer, which means that's factorable. Third term's negative, so our signs are opposite. Factors of our x squared are x and x. Now factors of 10 are 1 and 10 or 2 and 5. Which one do we want to use first? We're going to do 2 and 5. 21. 1 and 21 or 3 and 7? Let's go 3 and 7. If we check this here, 2x times -7 is -14x. 3 times 5x is plus. Set both of these equal to 0, and then solve for x. So for the first one here, we would subtract 3 from both sides. Minus 2x is -3. Divide by 2. Minus x is -3/2. Add 7 to both sides. Divide by 5. X is 7/5. If we also have x is 0, x is 1, x is 8, and x is -7. So all those are our solutions there. I think this one here looks scarier than it actually was. Yes? The numbers were big, but that's because we had these other factors of 3 and 7 going in, as well as 8. All those bigger numbers made the numbers look bigger. Yes?
That's 7.
So just put the answers right there. Or you can put the extra work on a separate sheet of paper. Let's go through the work, and if we do, at the end, we'll go to another one. But I would list the other two there, for sure. Because which one are you looking at? Well, we need it equal to what? Yeah. Set it equal to 0, then graph. And then do exactly what we did here. If you don't find enough solutions. Well, I'm not going to worry too much about the table. Because what I want to get to first is this here, the fundamental theorem of algebra. Fundamental theorem of algebra states, if f of x is a polynomial function of degree n, where n is greater than 0, we actually have a polynomial function, n has to be 1, 2, then the equation f of x equals 0 has at least one solution in the set of the complex numbers. Well, not n. On the last problem, or the problem we just did for the homework, one of the solutions was that x was 1, yes? Ta-da, I made it a complex number. So it has at least one solution in the complex set. That's not a whole lot to that. But the corollary from it is important. Well, both of them are important. We use the corollary a little more than the other. If polynomial function is a polynomial function degree n greater than 0, then the equation f of x equals 0 has exactly n solutions. Provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3, and so on. So what does that mean? Well, looking at this here, what is the degree of this function? Degree is 3. Because the degree is the... So how many solutions does this have? That's 3. Incidentally, the solutions are -3, 4i, and -4i. But the main answer is that there are 3 solutions. How many zeros does x to the 4th plus 6x cubed plus 12x squared plus 8x have? How many solutions would this have? 4. Because the degree is 4. Incidentally, those solutions are -2, -2, -2, and 0. Well, I solved it ahead of time. Also, the book says what the solutions are. Because it's asking how many zeros are there.
Oh, so you only, it's just F.
How many zeros? It's 4. Here, how many solutions does this equation have? 4, because the degree is 4. How many zeros does this function have? 3, because the degree is? Yep. All right. Let's look at this one here. This one, we're actually having to find the zeros. Now, this one says, it tells us to find all the zeros of the function f of x equals x to the 5th plus x cubed minus 2x squared minus 12x minus 8. How many zeros does it have? 5, because the degree is 5. Okay. So when everything is all said and done, we should have 5 solutions. And any solution that is repeated, we will count it each time that it is repeated. So if a solution appears 2 or 3 times, we count it as 2 or 3. We count it each time. Does that make sense?
So we're not counting it as one.
Yeah. So if 2 appeared twice, we count it as 2 solutions. That's that's also why, if we think back to our section on quadratics, where I said that some of our solutions had 2, they weren't unique, but they were still 2 solutions, that's what it's talking about. But looking at this here, the number that we need to find at least is 3. Because if we find 3 solutions, we can use synthetic division to take it from a 5th degree polynomial down to a quadratic. So there's 2 ways to go about this. One is that we do our rational zeros. We list out all the rational zeros and then try them one at a time to see which ones work. Or, which I think the or is the preferred method, we take the graphing calculator and graph it. Figure all that out. X to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. Graph. Yes, you are playing probability. You're flipping a coin. And it's recording the number of heads and tails that do occur. Hit trace. You almost had it. Because right now you're flipping a coin 50 times. So yes. So that's just a probability simulator. Everybody able to graph? Second, quit. Skip. Yes. Same button. Now second, quit. Now, this is the graph we have. We can go second table. And 2 of the solutions we have are 1 and negative 1 and 2. So we have those 2 for sure. Now, as we look at the graph, where x is negative 1, it does look like it touches the x-axis but doesn't cross it. We've discussed this kind of a few times on and off, but we said anytime it touches the x-axis but doesn't cross it, it has an even multiplicity. So there's a chance that there's an even number of zeros at that location. So as we're talking multiple, so there's a good chance there might be 2, 4, 6, 8, 10 solutions there. Now, the way we can check that is, well, plugging it in multiple times and seeing if we get a remainder of 0. Now, we do know it'll work once, so we can use negative 1 first. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2. Negative 2 plus negative 2 is negative 4. Excuse me. Negative 1 times negative 4 is positive 4. Negative 12 plus positive 4 is 8. Positive 8, it would be negative 8, because negative 12 plus 4 is indeed negative 8. And negative 1 times negative 8 is positive 8. Questions on this here? And hopefully at this point y'all are getting very good at synthetic division. Again, the reason that this is helpful is we've taken it from a degree 5 down to a degree 4. Now we're going to do this again with another solution to take it from a degree 4 down to a degree 3. Now there's a chance -1 might work again, but we do know 2 works for sure, yes? So I would go on and try 2 first. For 2 reasons. 1, we know it works, and 2, we don't know for sure if -1 works twice. But with doing 2, the one that we know works, the number of numbers that we're going to be doing synthetic division with decreases each time. So if we do this with 2, 2 times 1 would be 2. -1 plus 2 is 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -4 plus 8 is 4. 2 times 4 is 8. And -8 plus 8 is 0. Questions on this here? We're good at this so far, yes? All right. I want the camera back. But for us, what we're going to look at is something that really the textbook, if we were following it systematically, did not cover, was even multiplicity, where it hits the x-axis at -1. Because it doesn't cross it, it has an even multiplicity. There's an even number of zeros at that location. So what we can do is try -1 again. Bring down the 1. -1 times 1 is -1. -1 plus 1 is. -1 times 0 is. 4 plus 0 is. -1 times 4 is. And it does work. So I can get that. So -1 works twice. And if we plug the variables back in, 0 is our remainder, 4 is our term without x, 0 is our term with x, and 1 is our term with x squared, leaving us with x squared plus 4 is equal to 0. Incidentally, the other term, yep. So we would have gotten it if we factored it from a cubic or if we tried -1 again. Those we're going to have to find. Now we could have tried synthetic division here with -1 again or with 2, but unfortunately neither one of them would work. Also, at this point we do have it as a quadratic, and we do have it with just 2 terms, our x squared and our 4. Since we don't have a middle term, square root method. So the first thing we can do is subtract 4 from both sides, telling us x squared is equal to -4. And last thing we need to do to get x by itself is to square root both sides. Square root of x squared is equals plus or minus. So we need to take the square root of -4. It is a domain error, but the negative comes out as, and the square root of 4 is, because the yellow calculators will not take the square root of the negative. So we have to take the negative out as I. Then we can take the square root of what's left. which would be the square root of 4. Does that make sense? So the last two are plus or minus 2i, which does give us our 5 solutions because we have -1, -1, 2, and our positive negative 2i. And that's it. Questions on this here? And if you're wondering, yes, you could have factored it at cubic if you notice that's what it was. We feel good with this one here? Yes? We're ready for the next one. X cubed plus 7x squared plus 16x plus 12. Again, we could go straight to the rational zeros, which for us here would just end up being positive -1, positive -2, positive -3, positive -4, plus or minus 6, or plus or minus 12. And then we could go through plugging each one of those in to seeing what our answer is. Now we don't have any fractions because the value of q is 1. Or instead of doing that, we do have a nice graphing calculator. Let's let it do some work. Clear that out. X to the third plus 7x squared plus 16x plus 12. Now looking at this function here, how many solutions should we have? 3, because it's a cubic, yes? Now the number of solutions we want to get from the graphing calculator or our rational zeros is at least 1. Because if we get 1, we take it from a cubic down to a quadratic, and we have ways to solve a quadratic. What would even be better than 1 is 2, because then we just have a linear term. We add or subtract and then divide. And even better than 2 would be 3, because if I have 3 solutions, we are done. We have them all. It does look like we have at least 1. And if we look at the table, we have 2, -3 and -2. Now there's a good chance one of these is going to repeat. We just need to figure out which one. We bring the 1 down. -3 times 1 is -3. 7 plus -3 is 4. -3 times 4 is -12. 16 plus -12 is 4. -3 times 4 is -12 plus 12 is 0. We also have -2. We'll do it again. 1 times -2 is -2. 4 plus -2 is -2 times 2 is, and 4 plus -4 is there we go. At this point here, we'll plug the variables back in. 2 is our constant term, our term without a variable. 1's our term with x. This is why it's nice when we have all of them except for 1, because it's a little nice equation. -2 from both sides. Minus x is 2. Is -2, yes. So our solutions for this are -3, -2, and -2. And that's it. Questions on this here? We feel good with this one? Let's look at this one here. This one here is a degree 5, so we should have 5 solutions. X to the 5th minus 3 x to the fourth plus 5x to the third minus x squared minus 6x plus 4. Oh, yeah. So we do have at least two solutions. There's a good chance one of these is going to repeat. One of them is -1, and the other is 1. Yeah. And we're going to finish these notes. We're not going to finish them today. We'll finish them up tomorrow. I'm going to try -1 first. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is 4. 5 plus 4 is 9. -1 times 9 is -9. -1 plus -9 is -10. -1 times -10 is +10. 10 plus -6 is +4. And lastly, -1 times 4 is -4. And our 4 plus -4 gives us 0. Now the next one we can try is 1. 1 times 1 is 1. -4 plus 1 is -3. 1 times -3 is -3. 9 plus -3 is 6. 1 times 6 is -10 plus 6 is -4. 1 times -4 is and 0. Now one of the values did repeat. Which one looked like it was? 1 or -1? If we look back at the graph, it intersected or touched the graph at 1 but did not cross it. So we can try 1 again. Now our 1 times 1 is 1. -3 plus 1 is 1 times -2 is 6 plus -2 is, and 1 times 4 is 4. -4 plus 4 is 0. So we actually do have 1 repeated twice. Now we could try it a third time, but it's not going to work a third time. I will show you this here, because if we tried 1, 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 would give us +3. It's not 0. So it doesn't work. Now, 1 or -1 would give us something a little different, but it still would not be a remainder of 0. So at this point here, we've got to put our variables back in, which will tell us that we have x squared minus 2x plus 4 is equal to 0. Now, unlike the other day, there is no greatest common factor between these three terms. And we're going to have to use the quadratic formula. So the b squared minus 4ac, that kind of tells us if it's going to be factorable. So here b is -2, a is 1, and c is 4. So I could try doing that here. Second square root -2, yes. -2 squared minus 4 times 1 times 4. Domain error. So it is not factorable. Because what that's telling us is that whatever's inside the radical is a negative number. So technically speaking, it is factorable. We can technically factor it. But for us to be able to factor it, for the most part, we really need to know what the solutions are. Kind of if you think back to our radicals yesterday when we found the polynomial function, that we had x equals, then moved everything back over, and then put it next to each other. That's what we'd have to do. So you almost have to know the answers to factor it. Now b, in our case, is -2. So we have -2. Inside the radical, b squared would be -2 squared. Our 4 times a times c would be 4 times 1 times 4, all over 2a, so 2 times 1. Now our -2 is 2. Our 2 times 1 is 2. Now we already plugged the square root of -2 squared minus 4 times 1 times 4 inside the radical, all in the calculator, and it gave us an error. So let's see what the actual value of this is, and it is -12. So we can see why the yellow calculator threw it out, because it does not like negatives inside the radical. But we can take that negative out as I, which takes it from -12 to 12, and the square root of 12 is 2 square root of 3, which means the square root of -12 is 2i square root of 3. Questions on this here? Well, just like yesterday where we had 2 plus or minus the square root of 3, 2 square root of 3, we can reduce it. Same thing here. Because our 2 over 2, well, I'll just go on and write it out. We can break it up like this here, kind of like what we did yesterday. And our 2 divided by 2 is 1. Our 2i square root of 3 over 2 is I square root of 3. Thus, our 5 solutions are x equals 1, x equals -1, x equals 1 twice, x equals -1, and x equals 1 plus or minus I squared of 3. Questions on this here? We feel a little more comfortable with these? They are interesting in kind of how they work. There is a good number of steps to them, but they're not overly complicated, especially once we work with the graphing calculator.